All right, so it's time now to look at applications of trigonometric functions. We're going to start with ocean tides. So suppose that we all know, this is proven fact, that ocean tides are the periodic rise and fall of the water of the ocean, and it is direct effect by the gravitational attraction of the moon and the sun. And suppose this function that is given to you is right here, the h equals to 2 cos 2 pi t minus 4.5 divided by 12.4 plus 8 is used to calculate the depth of the water at any time during the day. Now, a couple of things. So yes, part of this equation is actually it is true, and part of it may not be true depending on which ocean side that you're looking at. But the 12.4, that is the time between the two high tides, and in this case the 4.5 represents the shift, the phase shift, or the shift time at first high tides. Okay, so that is what this equation is, and the 12.4 is basically the period, because the 2 pi in front really gets divided by the 2 pi within the formula for finding the period if the b value is given to you. So the question is, what is calculate the depth of the water to the nearest tenth of the meter at 10 a.m. So that means basically that's the time. Okay, so but we need to translate 10 a.m. into actual the number of hours, the t hours, starting at midnight. And starting at midnight, which is, so midnight is the 0-100 hours. Okay, that's how they call that. So 10 a.m. is 10 hours, and that is the t value. So what we need to do, we take this 10 and plug it back into the equation and then solve. So when you go ahead and substitute 10 for t, okay, so this is the t value, so here it is. All right, in the equation right here, we do the math. Now in this case, remember, you need to put your calculator in radians. You have to put them in radians mode. Must be in radians mode, because we're looking at the real world situation. So the actual rational numbers, that's what we're looking for. So when you do the math and you do it properly, remember, you deal with the bracket first, then you have to deal with the pi, multiply the whole thing, then you take the cos of that, you're going to get a small number, very small number, you multiply it by 2, you're going to get around 0.3221 something, and you add 8 to it, you get 8.32. And that's basically it. So at 10 a.m. the depth of the water, I call it the height, is from the level is 8.32 meters. Okay, now let's look at another example. This one is a typical example that shows up in any of the trigonometric application problems. So this one is the Ferris wheel with a radius of 22. If you go to any of the P&E events, they have that for kids to ride on, or adults for that matter. So this has a radius of 22 meters and rotates every 30 seconds. Riders get on at point L. Okay, so this is the point L. That's the lowest point, really. That's what that says. This is the lowest point. Make a note. And it is 1 meter. Great. So 1 meter above the ground. And suppose you get on at L again. So this is the value at L you're going to get on to start the rotation. Determine the sinusoidal equation that represents the height of the passenger at any given time. Now, whenever we talk about sinusoidal equation, you have a choice of cosine. So sinusoidal equations, you have a choice of writing the cosine equation okay, cos of function or the sine function. It doesn't matter which one you choose. Both of them are actually called the sinusoidal equation or sinusoidal function, and it's periodic. All right, let's go ahead and write all the information that we do know. Number one, let's start up with the vertical displacement. So what is that the midline is? So let's call it, we're going to call it vertical displacement. Okay, so the vertical displacement is, you have 22 meters is the radius of the Ferris wheel plus 1 meter above, so we know that is 22 plus 1, that will be 23 meters. This is where the midline of your equation or your function will be. Okay, so that is your mid value or midline. All right, very good. Next one, where is the maximum value, maximum height? Maximum height, we have 23 plus another 22 for the radius. Remember, this is the radius, right? So that will be 45 meters. That's at the highest it can possibly be from the ground. Where is the minimum height? Minimum height, it just tells you, is 1 meter above the ground. Excellent. The next thing we need is period, because we need to write the function. So the period, it tells you the period of the function is every 30 seconds, is 30. Okay, so it tells you the period of the function is 30, but in the equation we need to come up with the value of b. So this is 30 seconds, so 2 pi divided by b has to be equal to 30. That means b must be equal to 2 pi over 30 or pi over 15. Okay, pi over 15. Excellent. So we have that's equal to b. So simplified form. Great. Now we're going to go ahead and write the equation. And remember, at what point you're going to get the maximum? If it's going, the full period is 30. And let's suppose we're going to start with the cosine function. So we're going to use cosine function here. Okay. So that means that at t minus half of, if you think about the cosine function, halfway through the period, you're going to hit the maximum. Okay, now it is a cosine function, we were talking about that. So halfway through, so this should say t minus 15 on your phase shift. Excellent. Now let's go ahead and do the equation. So we know that based on the vertical displacement and maximum height, we know that the amplitude is 22. So here's your amplitude right there. Okay, then we have the cosine. Then we're going to have the b value, which is pi over 15, which we got it there. Then we're going to have the phase shift that gives us the time at which the maximum height happens, and then the vertical displacement, which is your midline. This is the equation of this scenario, the sinusoidal equation that represents the height of the passengers at any given time, t. Okay, so that is where the equation is being used. You plug in the value for t, and then you can find the exact location in terms of height of any given passenger. So when you take the 12 seconds and plug it into the t value right here, okay, now notice that the maximum height you will reach at 15 seconds. So the 12 seconds, your maximum height, which was 45 meters, has to become very close to 45. So when you do the math, when you plug it all in and you do the math properly, make sure that you do, make sure again in radians mode, your calculator in radians mode, you're going to get 44.9987 and more decimals. And that just proves to you that at 12 seconds, you're only 3 seconds away. And since the Ferris wheel is still turning, and it's turning in a decent speed, then you notice that you're very close to the top. Okay. Now, if it was, let's say, the height at 5 seconds, then you plug in 5 in there, and then you notice that you're significantly, of course, lower, okay, in terms of the height. All right, now in terms of the graph, how are we going to graph this? Now if we have to graph this, so when we want to sketch this graph accurately enough but to scale kind of a thing, we can start at 1 because we know that the passengers, they get on the Ferris wheel at 1 meter above the ground, and then the maximum that they're gonna hit is at 45 and at 15 seconds. So this is the time, this is the height, okay, and this is all in meters, these are all in seconds, just to make sure. So what will happen is that, and then you come back to the one at 30 seconds as a full cycle. So basically what you will have this midline that you will have for the graph so that you can see the midline, okay, and this is, so the graph goes up and then it comes down and it is symmetric and it stays like that, and then if you continue going, it's going to continue moving in a cyclical fashion because it's periodic. Okay, so this is the sketch of it. It's very important that you can quickly sketch that. Now, is this the only equation for this scenario? No, it is not. You could use a sine function. You just have to shift this the cosine function by a quarter of the phase shift. Okay, so in this case you could easily get a new function that looks like sine function, and it will look like, so the amplitude will be the same, the period will be the same. The only thing that phase shift now is going to change by a quarter of the shift for the cosine, because so that you can get sine, and that would be, and then plus 23. Now remember that the sine of theta equals to cos of theta minus pi over 2. Okay, so remember that this representation is always true, okay, or sine theta or cos theta equal to sine theta plus pi over 2. It doesn't matter. So you will, if you graph this, you will get the exact same graph. Okay, and simple as that. That's what you got to do. So you got to do a lot of these questions so they can get a hang of this. Every question is different. I'm just showing you some tools to use, but that's how you have to do it. Okay.